Now, I know you want to get started developing on Hedera, but before we do that, we still need to cover some core concepts in Hedera. By the end of this video, you'll be able to describe core concepts in Hedera like accounts, different types of transactions, queries, and confirmations. Accounts, core components. Accounts are the central starting point for Hedera. Accounts are stored on the public ledger and hold Hbar, which, as we learned in the previous video, are mainly used to pay for transaction fees, as well as for covering the security of the network. Accounts can be created, updated, or deleted. With regards to account creation, it can be done by one of two methods, either by using an existing account or by using an alias. There are several components to an account. Let's go through each one of them. Account ID. Each Hedera account is represented by an account ID. It is used to reference specific accounts in transactions and queries. Account IDs follow the format of XYZ, where X is the shard number, shard ID, that defaults to 0 as Hedera only performs in one shard. Y is the realm number, realm ID, that defaults to 0 as realms are still not supported yet. Z, account number or account alias, the account number. Every Hedera account is assigned a unique, immutable, system-generated account number upon creation. This non-negative 8-bit number is used to identify the account and all the transactions and query requests on Hedera. The format of the account number ID is shard number, realm number, account number. Example 0.0.11, and it's provided in the transaction receipt or the transaction record associated with the account's creation. An account alias will be given when the account is created by transferring an asset to an account alias via the auto account creation flow. The alias can be of type public key or Ethereum virtual machine. A public key account alias looks like shard number, realm number, alias, where alias is the public key. An EVM address account alias looks like that: shard number, realm number, alias, where alias is an EVM address. It is important to know that all accounts have an account number alias, which is a hex-coded form of the account number prefixed with 20 bytes of zeros. The account number alias does not contain the shard ID and the realm ID, and this account property is not stored in a consensus node state. Account memo. A memo is a brief note associated with an account in the ledger state, viewable via a network explorer. Limited to 100 characters, this account memo can be modified or deleted anytime, with any changes requiring the account's key signature. Account nouns. On Hedera, accounts can process Ethereum transaction type via the EVM on a consensus node, and accounts NONC set to 0 by default is an increasing count of Ethereum transaction type submitted by the account. Automatic token association. Hedera accounts usually need to approve custom tokens before they can be transferred. This involves the receiving account signing in a transaction for the token association. However, with the automatic token association feature, up to 5,000 tokens can be approved automatically without manual pre-authorization. For accounts needing to hold more than 5,000 custom tokens, each additional token must be manually approved. The total number of tokens on an account can hold is limitless, and the settings for this feature can be altered after the initial setup. Balances. Upon creating a new Hedera account, an initial Hbar balance can be allocated. This is optional, and the amount, if any, is deducted from the account funding the creation. Hedera accounts can store balances of Hbar as well as fungible and non-fungible tokens, NFTs. These balances can be seen on the Network Explorer and can be accessed through the mirror nodes, REST APIs, or consensus node. Keys. Every Hedera account needs at least one key when created, which, if absent, leads to transaction rejection. The key holders can authorize token transfers and modify account properties, including balance, memo, keys, etc. Optionally, accounts can have multiple keys, resulting in a multi-signature account where transactions require more than one signature. The specific signing requirements depend on the account key structure. Receiver signature required. Accounts on Hedera have the optional feature to mandate the account signature for any transaction depositing token. By default, this feature is deactivated. If activated, the account signature is compulsory for transactions depositing tokens. This setting can be changed after the account is created.
Transactions. Transactions are requests sent by a client to a consensus node in the network to be processed. As mentioned in the earlier steps, every transaction has an associated transaction fee that is required as payment to the Hedera network. A transaction generally includes the following: 1. node account, the account of the node that the transaction is being sent to. 2. Transaction ID, the unique identifier assigned to every transaction that is submitted to the network. 3. Transaction fee, the maximum fee the paying account is willing to pay for the transaction. 4. Valid duration, the number of seconds a transaction should remain valid before it expires. All transactions have a validity duration up to 180 seconds. 5. Memo, a string of text up to 100 bytes of data. 6. Transaction, the type of request. 7. Signatures, result of verifying the authenticity of a transaction. Transaction ID, let's dive a bit deeper into transaction IDs. Each transaction has a unique transaction ID. The transaction ID is used for purposes such as obtaining receipts, records, and state proofs, as well as internally by the network. The transaction ID is composed by using the transaction valid start time and the account ID of the account that is paying the transaction ID. The transaction valid start time is the time that the transaction begins to be processed on the network. The transaction valid start time can be set to a future date and time. As mentioned earlier in the previous steps, transactions have a validity of up to 180 seconds. If the transaction is not accepted in this time frame, the transaction will expire and it will have to be created, signed, and resubmitted again. Nested transactions. Now that we know more about transactions, let's explore the concept of nested transactions. A nested transaction is a type of transaction that involves grouping multiple transactions together and treating them as a single unit. This is typically used when a user wants to bundle several transactions into one single transaction. The top level transaction that a user submits is a parent transaction. Each subsequent transaction the parent transaction triggers as a result of the execution of the parent transaction is called a child transaction. Nested transaction ID. Parent and child transactions share the payer account ID and transaction valid start timestamp. The child transaction IDs have an additional nonce value that represents the order in which child transactions were executed. The parent transactions have a nonce value of 0 and the nonce value of child transactions increment by 1 for each child transactions executed as a result of the parent transactions. This is more like an array and it follows the following format. Nested transaction records. Nested transaction records are returned by requesting the record of the parent transaction and setting the function set include children value to true. Child transaction records include the parent consensus, timestamp, and the child transaction ID. However, in some cases, it's possible for a child transaction to be triggered before the parent transaction is added to the network. In cases like this, the parent consensus, timestamp, and the child transaction won't be filled. Nested transaction receipts. Nested transaction receipts can be returned by requesting the parent transaction receipt and setting the boolean value equal to true and return a child transaction receipt. Child transaction fees. The child transaction fee for the child transaction is included in the record of the parent transaction. The transaction fee will return 0 in the child transaction. Another interesting type of transaction that the Hedera network allows are scheduled transactions. A scheduled transaction is a transaction with the ability to collect the required signatures on a Hedera network in preparation for its execution. Unlike the other Hedera transactions we covered in the previous steps, scheduled transactions allow you to queue a transaction for execution in the event you do not have all the required signatures for the network to immediately process the transaction. When a scheduled transaction is created, the network creates a scheduling entity. This scheduled entity an identity ID, just like accounts, tokens, etc., called a schedule ID. The scheduled transaction can be referred to as the outer transaction, while the scheduled transaction can be referenced as the inner transaction. Signatures are appended to that transaction by submitting the scheduled signed transaction. The scheduled signed transaction function requires the schedule ID of the scheduled transaction that the signatures will be appended to. A scheduled transaction has 30 minutes to collect all the required signatures before the scheduled transaction can be executed. If it fails, it will be deleted from the network. Scheduled transactions can be queried using the scheduled get info function and will return the following information. 1. Schedule ID. 2. Account ID that created the scheduled transaction. 3. Account ID that paid for the creation of the scheduled transaction. 4. Transaction body of the inner transaction. 5. Transaction ID of the inner transaction. 6. The current list of signatures. 7. The admin key, if any. 8. Expiration time. And 9. Timestamp of when the transaction was deleted, if true. As covered in earlier steps, Hedera transaction IDs are composed of the account ID and transaction valid timestamp. However, for scheduled transactions, there's an additional schedule parameter at the end of the transaction ID. The transaction ID of the scheduled inner transaction inherits the transaction valid start time and the account ID from the scheduled outer transaction. Scheduled transaction receipts. The transaction receipt for a scheduled transaction contains the new scheduled entity ID and the scheduled transactions ID. The scheduled transaction ID is used to request records for the inner transaction upon successful execution. Note that the scheduled entity ID is a unique identifier for the schedule, whereas the scheduled transaction ID is the ID of the transaction that will be executed by the scheduled transaction. Scheduled transaction records. Transaction records are created when any of the following situations occur. 1. Scheduled transaction is created. 2. Signatures are appended. 3. Scheduled transaction is executed. And 4. If the scheduled transaction is deleted by the user. The scheduled transaction includes the ID of the schedule the record is associated with. We can query for transaction records of inner transactions after their successful execution using any of the following methods. Poll the network for the specified scheduled transaction ID. Once the scheduled transaction executes the scheduled transaction successfully, request the record of the scheduled transaction using the scheduled transaction ID. 2. Query a Hedera mirror node for the scheduled transaction ID. Or 3. Run your own mirror node and query for the scheduled transaction ID. Queries and confirmations. Queries. In Hedera, a query is a request for information from the network. Queries are processed only by the single node to which they are sent. Queries are subject to fees, which are paid with Hbar. The user will not receive a refund if a user overpaid for the query. To determine the appropriate fee for a query, the user can ask a node for the cost by using the cost_answer query. This is a free service. Confirmations. Once a transaction has been submitted to the network, the user may seek confirmation of it being successfully processed. There are 3 types of confirmations available. 1. Receipts. 2. Records. 3. State proofs. Receipts provide minimal information describing whether or not the transaction was successfully processed in a consensus. Receipts are generated by default, they're free, and they persist for 3 minutes. Records. They provide detailed information on transactions such as consensus, timestamps, or results of a smart contract call. Similar to receipts, records are generated by default and are persistent for 3 minutes. State proofs. These are coming soon. In addition, when querying for a record, users can use their client to ask for state proof. A state proof has access to information about that record in the consensus state. This information includes signatures of most of the network nodes. Because a supermajority of the network cryptographically signed state proofs, they are secure and potentially admissible in a court of law.
Let's go through a quick summary of the points covered. Accounts are stored on the public ledger and hold Hbar. Each account consists of several components. Transactions are requests sent by a client to a consensus node in the network to be processed. Nested transactions is a type of transaction that involves grouping multiple transactions together and treating them as a single unit. Scheduled transaction is a transaction with the ability to collect the required signature on a Hedera network in a preparation for its execution. Queries are requests for information from the network. Confirmations are produced after transactions have been submitted to the network. There are 3 types of confirmations available: receipts, records, and state proofs. Now, I hope this video has been helpful in getting you started with programming on Hedera. If you have any further questions, you can contact me through x.com or comment down below in the video. Thanks for watching.